Hey guys, welcome to this lesson where we are going to find the area of regular polygons. So we have spent a lot of time last semester finding the area of other shapes that were, like rectangles, squares, parallelograms, triangles, trapezoids, that kind of thing. And now we are going to find area of all these shapes with a whole lot more sides. And also it's important to note that they're regular polygons, meaning all of the sides are going to be of equal length as well as all of the angles. So this method that we're about to do only works because of that property. So before I get into the notes here, I do want to just explain a little bit where this process is coming from. And so like if I were to draw some outrageous image, right, maybe it looks like this, who knows. Let's say I did something like this, right? Some outrageous figure, and I told you to find the area of it. You probably intuitively could look at this and be like, well, there isn't a nice formula for this because it's not any shape that I've learned about. It's just a random looking thing. But maybe I could break it up into shapes that I can find the area of and then add those all together. So like, for example, I could make a triangle here. I could make a rectangle here, and actually another rectangle, and then this, in a perfect world, I meant this to be like a half a circle, And so those are all shapes that I could find areas of relatively easily, and then I could have added them all together, right? And that would help me find the area of the whole figure. And that's pretty much the idea of what we're going to be doing with these polygons, is splitting them up and finding the area of a shape inside to find the area of the whole thing. So let's go ahead and get into it. It's a 6-step process, and step 1 is where we are going to go ahead and make lines inside of our shape such that we split it into triangles. Alright, so basically I'm going to draw a line from the center to every vertex of my shape. That is how I'll split it into congruent triangles. All of these triangles are identical. Alright, and how many triangles were we able to make? Well, 1, 2, 3, 4, 5 triangles. Okay, and just to get us thinking, like how might this help us find the area of the whole shape? Well, if we were able to find the area of a triangle, then we can figure out the area of this whole thing, because this whole thing just consists of 5 of the same triangle. Alright, on to step 2. Now that we've made our triangles, we are going to find the central angle. The central angle, if you guys remember, is equal to 360 divided by n. And also, just as a reference, here in the center, all of these are central angles. And notice how they all, when they're next to each other, make a circle, which is why they add up to 360. So if I want to find one of them, I just have to divide 360 by however many there are so that I can equally distribute all 360 degrees to all of these angles. Alright, so to find this one angle, I should do 360 divided by 5 because there are 5 triangles. Okay, and that's going to give us an angle measure of 72. So what that tells me is that each one of these angles is 72 degrees. I'm going to go ahead and label the one right here. In fact, we could do all of them. Okay, these are all central angles. They're called central angles because they all meet at the center. Right, that was step 2. On to step 3. Find the length of the base of one of the triangles that you created in step 1. So typically we just stick to this bottom triangle. The base of the triangle, and let's go ahead and highlight this triangle that we're paying attention to here. This one right here. We want to know what the length of this base is on this triangle. And hopefully, if you just look at this without overthinking it, you'll notice that the length of the base is just this. The base of this triangle is 8. Sometimes I will give you a base, and sometimes I'll give you something else. In this case, I gave you the base, so you didn't have to do a lot of work there. Alright, and all these little pieces that we're finding, we're going to need them later on, so, this is where you got to keep track of all your information. Alright, Step 4. Here, we are going to need to find the height of a triangle. Now, the reason we're finding the base and height of this triangle is because the area of a triangle involves the base and height. We're just finding information that we need in order to find the area of a triangle. So, the way this is going to work is I will again focus on that same triangle right here, this bottom, and I'm going to kind of zoom into it. Okay, so what I've drawn here is like a big version of that triangle. And then we go ahead and split that triangle in half. The reason we're doing that is because we're drawing in the height. Okay, this line represents the height of this triangle. And it also happens to split our triangle perfectly in half. So I'm going to go ahead and call this X because, well, yeah, I'm going to call it X because we don't know what it is and we need to find it. In class I had called it H, but I don't want you to confuse that with hypotenuse, so we're calling it X now. Alright, and just keep in mind that that is the height. Now, I'm going to go ahead and zoom in to 1/2 of this big triangle. That's this right over here, because that's what's going to help me find the missing piece here. So now I know when I drew that vertical line down, I created right angles. So that's why I have this right triangle. There's a couple things I know about this triangle. First of all, I know the base of it because this one, the big triangle, had a big base of 8. But if I split this triangle in half, I would have to split that 8 in half too. So this becomes 4. And then additionally, I knew that this angle up here, the central angle, was 72 degrees. So I also have to take that 72 degree angle and cut it in half as well. That gives me a 36 degree angle. Alright, so now that's all the information I know about this triangle, but I have everything I need to figure out what that missing piece is. Let's go back and remember our good friend SOHCAHTOA. I'll write that right over here. Alright, so whenever we're doing a SOHCAHTOA problem, you have to start by labeling your sides. Hopefully you would recognize that right here at the 4, it's the farthest away from the angle, so that's going to make it the opposite side, so I'll put an O. And then this X is right next to the angle, but it's not the hypotenuse because it's not the longest. So we'll put an an A right over here. This side is the H, but we don't care because it's empty, so we ignore it. So now we have what we need to pick our trig ratio. Because we're dealing with O and A, I know that I need to use TOA or tangent. With that information, I am ready to set up my proportion and start the process to solve. Alright. Oh, that's a little thick. Yikes. Alright, so oh my goodness. I'm struggling. Okay, so tangent of 36 over 1 equals O over A. My O is 4, my A is X, so I'm going to do 4 over X. Alright, so now that I've done that, I'm ready to cross multiply. This diagonal, 1 times 4, is going to give us 4. This diagonal is literally just going to give us X times tangent of 36. We can't really do anything with that right now. Alright, so now we need to solve for X. The problem is that there's a tan 36 being multiplied by X, and in order to move it over, we have to do the opposite of multiplication. So we have to divide both sides by tangent of 36. That way, we can cancel it out of the right side and move it to the left side. So this is what you have to type in your calculator. So let's go ahead and pull up our calculator. Turn it on. 4 divided by tan 36. All right, 5.51 will work. All right, and this is the height of my triangle. All right. Something I want to note here, which I will come back to later, is that in this problem I gave you the base and you had to find the height, but sometimes you have to find the base and I will give you the height. So it just depends on what you're working with, but we'll eventually do an example like that. All right, on to step 5. Now that we have the base and height of the triangle, we can find the area. So let's first remember what the area formula is for a triangle. It is base times height divided by 2. So recall that the base of my pentagon, or sorry, my base of my triangle was 8, and my height was 5.51. So let's just write that down here so we don't forget. All right. So with those pieces of information, I can go ahead and plug this stuff in. Base times height divided by 2. And this just means area of the triangle. Alright, so let's go ahead and plug that into our calculators. We have 8 times 5.51. Then we're going to divide that by 2. We'll get 22.04. Alright, so this is the area of the triangle. So it's very easy to just get excited and think you're done at this point, but remember the goal, right? The goal was to find the area of that whole pentagon, right? This whole thing. We only found this one piece. So now our last step, step 6, is to multiply that area that we just got by how many triangles there are. So our area was 22.04, and we had 5 triangles, so we have to multiply it by 5. And if you forget where that 5 triangle thing came from, just look back at this pentagon, right? We had 1 triangle, 2 triangles, 3, 4, and 5. 1, 2, 3, 4, 5. And the amount of triangles will always match the amount of sides, too. Oh boy. Okay. So now I need to just calculate that. I'll get 22.04 times 5. I get 110.2. And remember from our area unit, area and perimeter, if I don't have any units, you guys can just use the word units. And for area, it's always square units. All right, and that is how you find the area of a polygon. Something I want you to keep in mind is if I had given you a pentagon, let's say we're still working with the pentagon, and instead of the base, let's say I gave you the height. All right, so let's say I gave you the height, and the height was 4. In this scenario, you still need to break things up into triangles. The steps are the same, but I just want to show you how it could be a little bit different in the rest of the process. Okay, so you still zoom in on one of the triangles. You take that one triangle. This is the height. This is 4. But in this case, we don't know the base. So you're still going to cut this triangle in half, but we know that this is 4. We don't know this part, so this is what we have to find, and this would still be 36. So at this point, once you find out what this is, you find that by doing 4 times tangent of 36. All right, this is going to get you about 2.91. So if that's our x, we have to remember that our base is going to be double that. That's the big thing here. The reason for that is 2.91 goes here, but we had originally split our triangle in half. So the base is actually like 5.82.